Let's take a look at another example. This example says, well, solve the following differential equation. So let's take a look at the example. This example is the second derivative of y plus y is equal to 0. So let us assume that y is equal to a power series c sub n x to the n starts from 0 to the infinity, which can be written as c sub 0 plus c sub 1 x plus c sub 2 x squared plus the rest of the terms. That's how we define a power series. Let's take the first derivative. The first derivative becomes 0 plus c sub 1 plus 2c sub 2x plus 3c sub 3x squared plus the rest of the terms. So as you can see, this series, after you take the derivative, becomes the sum and starts from 1 to infinity. This is what we discussed in elementary calculus. You can take the second derivative. The second derivative becomes, again, you can start taking the derivatives. This is just 0 plus 2, c2 plus 6, c3x plus the rest of the terms, or you can write it as the sum and starts from 2 to infinity, n minus 1, cn x2, n minus 2. Can take the rest of the derivatives if you have higher order differential equations. Now let's substitute. Our goal is to find a pattern, a relation between the coefficients. Okay. So our second derivatives is equal to the sum and starts from 2 to infinity, n minus 1, cn x2 n minus 2 plus y. Y is just the sum and starts from 0 to infinity, cn x to the n, and on the right hand side we have a 0. Very good. So what does it tell us? It tells us to combine these two series, we need to have the indices starting at the same number, at the same value. So let us shift the index of summation by 2. Shift the index by 2. So let's see what happens here. Let's move this to the other side. Your first series becomes series and start from 0 to infinity, and then you add 2 to each n. You get n plus 2 times n plus 1, and your cn becomes cn plus 2, and your x becomes x to n minus 2 plus 2, which is x to the n. You copy down the second series and starts from 0 to infinity, cn x to the n equal to 0. Now you're allowed to add these two series. This becomes one series and start from 0 to infinity, and you have n plus 2 times n plus 1, cn plus 2 plus cn x to power n equal to 0. So as you know, this series is equal to 0 if the coefficient is 0. Well, what do we see here? We see that cn plus 2 becomes negative cn divided by n plus 2 times n plus 1. This is a relation that we find between the elements of the coefficients. So let us analyze this a little bit. C sub 2 is negative c sub 0 divided by 2. C sub 3 becomes negative c sub 1 divided by 3 times 2, which is just 6, or let's write as 3 times 2. Okay, what about c sub 4? C sub 4 is negative c sub 2 divided by, we get 4 times 3. C sub 5 becomes, well, negative c sub 3 divided by 5 times 3. You're trying to find a pattern between these. But c sub 2 is equal to negative c sub 0, right? So your c sub 4 becomes c sub 0 divided by 4 times 3 times 2, or just 4 factorial. Your c sub 5 becomes, if you plug in c sub 3 here, c sub 1 divided by 5 factorial. So what do we see here? We see a pattern between even indices, and we see a pattern for odd indices. We can write it this way. C sub 2k is equal to negative 1 to the power k c sub 0 divided by 2k factorial, and c sub 2k plus 1 is equal to negative 1 to power k c sub 1 divided by 2k plus 1 factorial. So your solution, let's go back to the solution. This is the whole point of writing this differential equation and trying to solve this differential equation. Let us go back to our general solution that we're trying to come up with. So this general solution can be written this way. Substituting everything back to this general solution, it gives us y, which is a function of x, equals to, we have c sub 0 parentheses 1 minus x squared divided by 2 factorial plus x to the 4th over 4 factorial minus x to the 6th divided by 6 factorial plus c sub 1 x minus x to the 3rd divided by 3 factorial plus x to the 5th divided by 5 factorial minus the rest of the terms, and this is the general solution that we have. But remember, what was the definition of this expansion? What was the definition of this expansion? Y of x is nothing but c sub 0 times cosine x plus c sub 1 sine x. So we found the general solution for this differential equation.